Okay, now we start session 5.2, which is equation of value. Equation of value. Okay, in the previous session, we saw this equation, which is for the simple interest. We call it equation 1. This equation was called equation 2. This equation was called equation 3. And this equation is equation 4. No, this is equation 2b. This is equation 2b. This is equation 2b. And then the one we call equation 3 is when we say interest is this minus this. Okay, that is what we call equation 3. All right, so you see we are looking for the future, and P is the present, or we call it the principal. When you were in high school, they always call it principal, but we are more, of course, it's still principal, and it's also called initial value, but we emphasize more on present value. It's called present value. This is the future value or the accumulated value, that is S. Okay, now you will discover that when we want to find the future value, this is the formula, but we can make P also the subject of the formula. Now, if I want to make P the subject of the formula, I just multiply both sides by this value, by this one. I just multiply both sides by this value. So that will give us P equals to S over 1 plus Rn. Okay. Then I can use my power, like in the exponential function we have done, then to be S1 plus Rn minus 1. So the present value, when we have this future value, is given as this. So when we are finding the future value, the power is positive 1, if we like to put 1 there. But when it is present value, then it is negative. So take note of that, it is negative when it is present value. So the same thing for the remaining equation. When it is compound interest, it is positive n, but when it is present value, for that one is negative n. But don't forget we are looking for the present value with the future at the right-hand side. But here we are looking for the future value with the present at the right-hand side. Okay, the same thing for this formula. This is the future at the right-hand side. We are looking for the present value at the left-hand side. We are looking for the present value. The same thing for the equation of the continuous interest. Okay, if we are looking for the present value, then it also takes the negative power. Please take note of that. So don't mix things up. Okay, so you don't write like this. Don't write like this. S equals to P1 plus R negative N. No, this is wrong because we are looking for the present value, the future value, so the power is supposed to be positive. Or don't write like this. Don't write like this. No, this is wrong. This is wrong because we are looking for the present value. The exponent or the power is supposed to be negative and not positive. Okay. Okay, so with that, you will notice these things that have been mentioned already. Negative when calculating present value, and positive when calculating future value. Negative when calculating present value, positive when calculating the future value. Okay, so we are going to be making use of timelines. Timeline is a graphical representation of a problem, just like we have in the real line. So this one is a timeline that we start from our initial value and to the number of how many years we need it. If the number of years is 8, and then we indicate those values in the middle. So that is the timeline. So we are going to be using it to indicate information given to us. Okay. All right. Now, let's take note of these two things. Number one is what we call time value of money. And then number two is what we call equation of value. Okay, now in time value of money, we want to know how money loses its buying power, its buying value over time. Okay, for example, if we can buy 2 liters of Coke for 100 rand now, 2 liters of Coke, 2 liters, 6 2 liters rather, 6 2 liters of Coke for 100 rand now. Now, in 6 years to come, or in 5 years to come, how many 2 liters of Coke can 100 rand buy? Of course, it's less than 6. Okay, in 5 years to come. Of course, it's less than 6, except the world is now better now. And things are surplus now. But if not, then it will be less than 6 2 liters of Coke. So let's assume it is 3. So in 5 years to come, we can only buy 3 2 liters of Coke for that same 100 rand. For that same 100 rand. So money loses its buying power over time. Okay. So now when we talk about equation of value, here now we have 6 2 liters of Coke, 6 2 liters of Coke for 100 rand also. Okay, for 100 rand now. Now in 5 years to come, now we want to see what will be the same 6 2 liters of Coke in 5 years to come. For how much? For how much would that be in 5 years to come? For how much would that be? Okay, your guess could be as mine. It could be 150 rand or 200 rand. Am I right? Okay, so it could be something around. It could even be 250 rand, depending, or 300 rand, depending. Okay, so please take note of the two. Now, so when we are dealing with this equation of value, we always calculate the equation of value at a fixed point in time. A fixed point in time. So when we pick a fixed point after you draw your timeline, you pick a fixed point and then you sum together all the payment, sum together all the debt and equate it together, then solve for what you are looking for. You sum together the payment, sum together the debt, and then solve for what you are looking for. Okay, please take note of that. Take note of this formula. We are going to make use of it very soon now. So in order to solve problem along this line, you must read the question carefully, sometimes more than once, and get the given fact and what is being asked. Draw a timeline for all the information given. Choose a fixed point on your timeline. And then use the formula, or the sum of payment on one side and the sum of debt on the other side, and then equate them together and solve. Okay. Now, don't forget the formula we mentioned before. When you are looking for a future of something, okay, you are moving from right, S when moving a number to the right on your side. So when we are dealing with S, we mean the power is what? Positive. And then when we are dealing with the present value, the power is what? Is negative. So that means when we are dealing with the future value, we are moving from right to left. So let's say this is it. This is right. This is our right. No, this is our left rather. This is our left. This is our left. And this is our right. Okay, so if you are moving from right moving a number to the right, you are moving to the right. So if you are moving this way, then it will be positive. Your power will be positive. But if you are moving this way, then your power will be negative. So if you are moving to the left, your power will be negative. If you are moving to the right, your power will be positive. Okay, please take note of that. Then we use the equation of value formula, and then we solve the question. Okay, let's take an example. Okay, a debt of 3,000, is due in 6 years. A debt of 3,000 is due in 6 years from now. Okay, now, the time now is 0. Whenever we are making now, that is 0. Okay. Is instead to be paid off by 3 payments. 500 now. Again. And then 1,500 in 3 years. And a final payment at the end of 5 years. We don't know the final payment. So we can represent that final payment by X. What would this payment be if an interest rate of this compounded annually? So that means my M is 1. So I can as well ignore it. Okay? It's assumed. Okay? All right? So now we want to find what is being paid now. Okay, I mean the final payment at the end of 5 years. So we draw our timeline. From 0 to, well, when now is 6. From 0 to 6. So this is my 6. Okay, I always like you to write the time or the year on top. Okay. So this will now be 6. Okay, this will be 6. Please take note of that. Now, that is 3,000 due in 6 years. 3,000 due in 6 years. So I can write my 3,000 here. I can give this one 1, 2, 3, 4, 5. Okay, so this is 1, 2, 3, 4, and 5. Okay. Now, instead to be paid off by this 500 now. So that 500 now will be 500 now. Okay. This is the debt to be paid. Let me use green and say, okay, that is the debt to be paid. 1,500 in 3 years. 1,500 in 3 years. 1,500 3 years. And the final payment at the end of 5 years. Okay, I don't know the final payment. Let the final payment be X. Okay, I can call this one X. Okay, so these are payments. If you like, you can shift this down a little. And say 3,000. But it's still on 6. So these are payment. And this one is the debt. Okay. So but it's still on 6. All right. So now it's compounded annually. So our rate is 6%, which is 0.06. Okay, that's our rate. All right. So you will see now we need to choose a point in time. Of course, the point to choose is the one that contains the unknown. So if I choose this point, then every other thing must go to this point. Is that okay? Of course, you can still choose this point or choose this point. It will work. If you work it right, it will still work. But let's always choose the point, the unknown point as the point to choose. Is that okay? So now, this goes to this. This goes to that point, and this comes to that point. All right. Okay, now you can now see that this one is going to the right. Am I right? This is the left side of this point. This point, this is the left side, this is the right side. And we say whenever we are going to the right, that is a future value. Okay, so that means the power will be positive. Whenever we are going to the left, that will be present. That means the power will be what? Will be negative. Okay, so don't forget that. So now, don't forget this formula. We are going to use this formula. Sum of payment. Sum of payment of all payment will be equal to sum of all debt. Sum of all payment will be equal to sum of all debt. Okay, so this is payment, but this payment to this x, we are going to calculate it to this x. So we are not just using, okay, is now, then you are not using the 0, no. So you have to calculate it. So it will be 1, 2, 3, 4, 5 to x. Okay, so that means we are going to have one of the payment is 500 into 1 plus our rate 0.06 raised to power 5. Okay, raised to power 5. Okay, raised to power 5 because this is 0.06. We are not dividing it by m because m is 1. Okay, so we have that plus another one plus this one to x is 1, 2. So 1,500, 1 plus 0.06 raised to power 2 is also positive because it's going to the right. Okay, then plus this x is a payment. This x is a payment, so it will be x. If you like, you can say plus 1.0.06 raised to power what now? 0, because it's f. It's raised to power 0, but since anything raised to power 0 is 1, we ignore that. Anything raised to power 0 is 1, so we ignore that. Okay, so it's standalone x, so that is the payment. Then must be equal to our debt. This is the only debt we have, and it's going to this side, and from year to year is 1. And it's 1 going back, so it's negative. So it's going to be 3,000, 1 plus 0.06 raised to power minus 1, negative 1. Okay, now this is what we have. Now we need to solve this. Press your calculator for this, and then you are going to get your x equals to 3,000, 1.06 raised to power minus 1 minus 500, 1.06 raised to power 5 minus 1,500, 0.06 raised to power 2. Okay, by the time you press your calculator for this, then you get your answer for this. Okay, that is how to get that. Please ensure that you understand.